Here's a question that broke the internet. Ask a large language model how many R's are in the word strawberry, and it will confidently say two, or some other wrong answer. So, why does the smartest AI in the world miscount letters in a single word? The answer hides in a step that an audience never sees, and that is the moment your text turns into numbers. Large language models don't actually read text, they process numbers. So, long sequences of integers. The text you type is just like an interface for humans. Every neural network is a giant pile of multiplications and additions. You cannot simply multiply the letter A. So, before anything else happens, every piece of text must become a number. The simplest idea is give every letter its own number. So, A is 1, B is 2, and so on. It may work, but sequences become extremely long. The word tokenization itself needs 12 numbers. The other extreme is give every word its own number, so short sequences. But English has more than 600,000 distinct words, and that's before any names, slang, typos, or any other language. So modern models pick kind of a sweet spot between letters and whole words. They use chunks called tokens. Some tokens are whole words, some are piece of words. The split is chosen by an algorithm called byte pair encoding. Take the word tokenization itself. The tokenizer slices it into token and ization, two pieces instead of 12 letters, compact and reusable across thousands of other words ending in ization. So every model carries a fixed vocabulary, typically around 100,000 tokens. Each one has a permanent ID, which is basically a number, token 0, token 1, token 2, all the way up to 100,000. Watch what happens to the phrase hello, comma, world. The tokenizer reads it left to right and turns it into a short sequence of ID numbers. That sequence is what the model actually sees. Very common words like the and is of each get their own single token. They show up so often that giving them a dedicated ID can save enormous amounts of space. Rare or made up words get sliced into smaller pieces. The word anti disestablishmentarianism becomes 6 or 7 tokens. Your last name might split into three. Spaces and punctuations are tokens too. A leading space usually belongs to the next word's token, which is why cat and space cat often have completely different ID numbers. When the model reads strawberry, it does not see S T R A W etc. It sees just two tokens, straw and berry. The individual letters are gone. Asking it to count R's is like asking you to count bricks in a blurry photo of a wall. So you basically have to guess, but you literally cannot see it. Tokenizers are trained on text that is mostly English, so English compresses well, about one and a third tokens per word. So Spanish and German cost closer to two, Chinese, Japanese, and Korean cost two and a half more, sometimes a full token per character. This is why language can matter for cost. So APIs bills by the token. Same paragraph in Japanese can cost 2 or 3 times what the English version costs. Same meaning, but tokens and the bills can get bigger. And the context windows you hear about is also measured in tokens. A novel in English might just barely fit. Same novel in Hindi might not. One detail to keep in mind is the tokenizer is trained once before the model itself. After that, it never changes. The vocabulary is locked. Every prompt forever uses the same fixed set of tokens. GPT, Claude, Llama, Gemini, each model family has its own tokenizer. The same sentence becomes different ID sequences depending on who built the model. Token counts will not match across providers. Those ID numbers are not the end of the road. Inside the model, each ID gets expanded into a long list of decimals called embedding. That vector is what actually flows through the neural network. But that is for another video, and I'll put a link to that video in the description. So the key takeaway is the following: text is just the interface humans use, tokens are the actual unit the model thinks in. Everything strange about how a language model handles spelling, counting letters, or different languages comes back to this single hidden step. So models see tokens, not letters. Different languages cost different amounts, and the vocabulary a model was born with is the vocabulary it basically continues with.